Okay. Hey everyone, and welcome to the SaaS developer community. This time live. Of course, you will be able to hear it after the fact. But if you are on the channel now, you're here live, and you are live with Miki, who is, first of all, a backend engineer, a founding engineer at Nile, who wrote, I would say, most of our backend. And he joins us today to talk to us about the work he did around multi-tenancy and how he used row-level security. He wrote a blog about it. And this blog yesterday completely blew up on Hacker News, and we got tons of questions. Okay, let's get Miki live, ask him a bunch of questions, and chat about all things multi-tenancy and row-level security in Postgres. So, Miki, welcome to the channel.
Thank you. This is my first podcast. Very excited. And a live stream too.
Yes, you are definitely taking it in hard mode, which is how we like doing things.
I'm excited.
If it's worth doing, it's worth doing, really.
Yeah, just go all the way. Just go all the way.
Exactly. Yeah. So it's great to have you. And your blog post pretty much had touched on three big topics. So unless people start asking questions, in which case I will take questions from YouTube, I will start with my questions, and I want to touch each of those topics. So you talked about multi-tenancy, you talked about row-level security in Postgres, and you also talked about what it really means to be production ready as opposed to a small POC just to check that things work. So I want to ask you about all three of them, and about multi-tenancy. You controversially, I think, chose a shared schema architecture, and a lot of the Hacker News comments were, why didn't you just use schema per tenant? Why didn't you just do a database per tenant? And those are maybe valid decisions. Can you talk us through how you got to, hey, one schema for many tenants?
Yeah. So I don't think there's a just blanket wrong solution, right? It just depends on where you are in the company, what your customers are asking for, the time investment, things like that. So for us right now, we're very early stages. We're iterating on our product, and we need something that, one, will allow us to move fast. And for now, that means a big part of that is minimizing on the operations. So something like a database or a schema first solution involves a good amount of operations work, which is really not ideal for us. And on the database per customer side, this is also it's a really heavy solution. It's obviously the most secure. It provides the highest level of data isolation, but it's also costly. And if customers were pounding down our doors, telling us this is the only reason why they would use us, and maybe we would do that, but it hasn't been something that people really, really want, and it would slow us down considerably.
Yeah, so I'm actually hearing two things. First, about really operational complexity, like how easy or hard it is to really manage a large fleet of databases and all that. And I have to admit that I agree with you. I was really surprised that some people think it's easier to manage a large fleet of database and to add some rules about access which rows. That's a very big surprise to me, because the row-level security, you do it once, and many databases, you kind of have to manage them forever. And we did that, and that was a lot of work. But the other thing you said that I think is really important for listeners who are thinking about which solution I pick, you said it depends on the customer. And if you're even if you don't talk to a specific customer, if your company is targeting those high-end enterprise customers, banks, the government, people who are super security conscious, if you're selling to the Apples of the world, who are very, very paranoid, you may need a very different solution than, hey, We are a product-led growth company. We sell to developers. We're actually mostly open source. We just need to download stuff and everyone to get started in a second, not us spinning up a bunch of databases in the background. Like totally different company.
Right. Yeah. It depends. Yeah. It just depends.
Yeah.
Also, I think with like the operations heavy things, the reason why a lot of people say, oh, it's not that bad is, well, at least one reason is, so we worked together at Confluent, and at Confluent, there were a lot of like operational heavy things. And I think they were probably like, they weren't that bad for me to deal with, but I imagine setting them up for the first time and setting up the tooling and figuring out the kinks, it would take a long time. So once that stuff has been figured out, maybe that investment pays off in the very long term, but as you're quickly iterating, it just takes a lot of time to get things right.
Sometimes let's say your TLS vendor provider announces that you need to rotate your keys. And suddenly you have about 1,000 clusters in which to key rotation. If you automated fast, props, you button and suddenly upgrade 1,000, which we did. But even if you click a button and it automatically upgrades 1,000 clusters, how many of them will hit an unexpected bug? Maybe in Kafka, maybe in Kubernetes, maybe in AWS, who knows? If you have 1,000, you will have, let's say, maybe 50 hitting an unexpected bug. Like it's 0.5%. It's not that unusual. I'm not going out there. So you need people to handle 50 concurrent incidents, or at least be ready for that, which is a bit insane. So obviously you roll it out over time, but you have a limited window of time, especially if it's a security thing where you really need to roll it out ASAP. So you're stuck balancing 1,000 incidents. And the nice thing about the shared database model is actually have multiple shared databases, but choose how to balance. Like you don't want every egg in one basket, but you also don't want 1,000 baskets. Okay, my jam is 20 baskets. Let's go with 20 baskets.
Right. Yeah, I think it's obviously a spectrum of shifting complexity from application to infrastructure, but at least if the complexity is in the application, hopefully it's easy to develop locally and you don't run into just kind of unexpected
and you have
errors.
all this flexibility. We got a lot of optionality. Like with your architecture, we can still do a database per customer, but someone who went all in on database per customer will have to do all your work to get to multi-tenant. So I feel like your solution actually gave us tons of optionality.
Yeah, I think at this stage it was the right one for us.
Yeah, absolutely. So we decided that, okay, Gwen, when we're going with shared database, this is what our architecture going to be like. You did a bunch of research and then you came to me and say, not only are we doing shared database, we're doing it row-level security. How did you get to that? How did you come up with, yes, this is how we're doing things?
Yeah, so we did start out at Nile using the classic where user ID equals whatever user ID you get from the auth header. Basically these dynamic queries, and I think we changed our authorization model or adding more access control features, or maybe both. And I just remember changing a bunch of these statements, and there was branching logic, and I thought, if this is what I have to do now, imagine we iterate like 3 more times on this a while, like after we have 20 more API endpoints, this is going to be horrible. And there's a good chance of us forgetting something, even though we're very competent. It's just, it adds up over time. It's like one mistake and you have a security hole. So I was scared about that and wanted a solution that would not rely on us to never, ever make errors. And so I looked for that and found it with row-level security. I read some blogs about it, saw it was surprisingly easy to do, and then talked with you and our other senior engineers, and got agreement that this actually would be a pretty good fit for us. And
you mentioned that you've seen it before in other places. It's not like, okay, there's a blog, therefore we're doing it in production.
Yeah. I mean, there are other products that use it as well. Like, it is a solution. I've never implemented it myself. And so, just looking at how it was actually done, it turned out to be a lot more straightforward. But I have seen it in products. I've seen it used. So
but I think it's important, right? I mean, you don't pick something just because you've read one blog. It's a combination of, I read a blog, it looks like something I can do. Just because I can doesn't mean I should. Let's go and figure out whether we actually should. And that's based on our prior experience.
Of course. Yeah.
Yeah,
that would be a wild decision to just change all of our multi-tenancy data model based on like one random blog. There's definitely a good amount of thinking done around this.
Yes, I don't think we would have been enthusiastic about that. Sorry, I have the mental image that you show up one morning and say, Gwen, I read this blog. I heard that this new thing is now trend. How can you use? Let's rewrite our entire code.
Actually, the PR is already merged.
I don't even know if to be impressed or so we decided that, hey, Postgres has this capability built in. It is safe, it is clean, it has all those architectural benefits that you detailed in the blog around the dry principle, around the separation of concerns, all those big ideas. But just because something is a good idea in architectural theory doesn't mean that it's actually easy in practice. And in your blog, you actually kind of shared a bunch of challenges. I was just wondering, like, viscerally, what was the thing that was there any moment that you were like, oh my God, I didn't realize that maybe I made a really big mistake? Like anything that surprised you that much?
There weren't really any big surprises. I guess it was so the one thing I did outline in the blog is I read those two other blogs, implemented the examples, looked good, went to do it in our infrastructure and our authorization model, and found that, everything is actually failing, as it should, right? Because row-level security fails everything by default. So I was like, why is everything failing? Nothing is being authorized. And I looked, and it turns out if you have a more complex authorization model, you have these recursive policies that cause infinite loops, and you need to get around that somehow. And obviously, if you're reading some blog, they give you the smallest example that's you can't possibly mess up. And so it just turned out with our actual data model, it was more complicated to do. And just as you're figuring out row-level security, things are always failing until they pass. It's kind of frustrating. It's good. It's like a great way to feel very confident about where you're deploying, but as you're figuring things out, it's super frustrating. So that was one thing. But
I liked how you said that. Yeah, and this is exactly how tests are supposed to work. Nothing works until you figure out how to make it work. That's kind of engineering.
Exactly.
But I can see how you implemented one thing and suddenly every test in the system is red. You're like, wow, this was actually some of them were supposed to pass.
Right. Yeah. Because unless you define all the policies correctly, then things are just not going to be authorized.
And I think in our case, especially the big Asian test suite, I think we basically our test suite basically models a scenario where someone signs up and then does a bunch of things. And if the sign up is broken due to row-level security, which you explained in the blog that sign up is actually a special case, you have to Basically, every test will fail until you fix sign up. You won't even get a signal anywhere else.
Right.
Yeah. And those details are matter, and not in every architecture sign up will necessarily be a special case. I think in the blog you generalized it a bit around the rules about the table. I think you talked about the definer versus owner rules.
Yeah, it was the
in the blog.
definer and the
Yeah,
definer and invoker functions. Yeah.
yeah. So it sounds you really had to map their model of who can do what to the model of who needs to do what, and that's basically what you worked through by example in your blog.
Right. Yeah. I through the blog, I basically went from the simplest possible, see this in a blog, try it out, it works instantly example, to here is our more realistic authorization model. It has some policies that reference the tables that the policies reference in them. And how do I do that? Because I'm probably going to have that when I try to implement this. And then, obviously some other things when actually deploying to production and building this, like logging and things like that, and testing. I also out on in the blog that you have to do.
Yeah, the things I'm slightly curious about is Twistle did it under some kind of time pressure, and in that slightly time pressured scenario, you still run into some surprises that to basically get you to learn more about the security model in Postgres and kind of reevaluate the mental model around row-level security. And usually when you reevaluate your mental model, you're kind of like, okay, there's like a lot of different things I can do, but you don't always have all the time in the world to experiment. Can you just give some general purpose advice unrelated to row-level security, how you balance things out? Because I think this is one of the things you do extremely well, and I value is that you balance speed and cool solutions.
Yeah. Well, yeah, I do think it's at least for me, it's there. I don't know what the word for this is, but it's skewed heavily at the beginning of like not knowing anything at all and then figuring it all out, and then things go a lot more smoothly. So at least for me, I guess this is very low level advice, but I tend to work pretty hard to figure things out initially. So like I'll work extra hours and try to really understand things to not break out of that flow. And then once I figure those things out, it's a lot easier for me. When I'm doing sort of more out there, I guess you could say cool solutions, it doesn't work for me as well to work at a more consistent pace. So that's one thing I do. The other thing, I think that's really the main thing that allows me to do this quickly. And then just figuring out really how to get very tight testing loops is super important. So for me, one of the things that really slows me down is if I'm figuring something out and just kind of poking in the dark, if every time I need to try to make a change, it takes me 5 minutes to test it, it's going to take me forever, and I'm just going to hate the whole process. So for us, setting up integration tests that we can run pretty quickly was super, super helpful. And also just figuring out the model well enough so I could log into the SQL query console and actually try some queries and have that work, because that's even faster than integration tests. That was super helpful for me. So really tightening that loop of let me try this, does it work? That was, if I got that down to like 15 seconds, and I was able to figure things out very, very quickly after that.
Yeah. Almost brings us to the next part. Like this kind of quick iteration, being able to really diagnose extremely fast is not just important when you're developing. It's important to when you figure things out in outside your local environment, like in your pre-production, later in production. If someone calls and says, hey, I cannot see, I think I created an entity instance and I cannot see it, what do I do? You need to actually be able to diagnose and figure things out. So can you talk us through what was needed to go from works on my machine to, hey, Gwen, you can release it and let all our customers know?
Yeah. So it was really, two things I would say. One is testing. That's the first thing. Maybe not what you intended with this answer, but I think if you cover as many test cases as possible, you just won't have as many customer requests coming in going, what the hell is going on? Nothing is working. So yeah, I forget the saying, but the best cure is prevention or something like that. And then after you do that, if something slips by, there's a bug, then it's just super, super helpful to have logging. And with row-level security, one of the things that's a bit tricky is the database sort of mixes with their requests. So the database and application context and request parsing and things like that, they all sort of mix together, and you need to, at least in Java, use something like thread local storage to track the user ID coming in all the way from the request to the database connection. And especially if you're doing this at first, you can screw things up. And again, hopefully catch them in tests. But then if you go to production, something happens, logging every point in the process where you think maybe this can be useful in the future, that's super helpful. You can always reduce the verbosity. You can set it to trace and never set your logging to trace if you want. And then if issues start happening, then you set it to trace. But at least just having it there initially when you ship the feature is super, super helpful. And another thing we did is, so we use Hibernate, and Hibernate has like a trace or debug logging mode. And it gives you a lot of details about the values you insert into the database, that the exact queries you're executing. It's super low level, and it helped us debug a few things. So that was super helpful.
I was told that we can actually change the long level dynamically in production if I want. So because sometimes it's hard to balance how much you need to see day to day in the log and yourself versus, oh my god, I'm doing something really serious, I need more details. So yeah, I don't know if if you're the one who did it, but I have it on good authorities that I should be able to do it. This is important though, like debugging production is hard if you cannot actually switch the log levels when you need it.
Yeah. And as I said, if you're initially shipping something, it's better to just err on the side of caution. Yeah, at least for like the first week. Logs are probably not that expensive.
No, it's not about cost. I would say you want to err on the side of developer usability. Like, right. As a developer, I want to see things that I need and are useful in a specific scenario, like what I need in this scenario may not be what I need in another. On the other hand, if you have too much information and you cannot find anything, you have to scroll pages and pages or write complex grep. I've been in a scenario where we had to write a job to find the logs because it was, like I think in the terabytes of logs, and if I remember correctly, Elastic kind of quit on us at some point, and we're like, okay, we need to bring in the big guns, massively scale it out to find this one line of logging. You never want to actually be there day to day.
Right. Yeah. That's actually, I think, for Hibernate, when you go to trace, it's a wild amount of detail.
Insane, yeah. I remember, like, there's a lot of stuff that's like, is it actually useful? Like, and that's a test, right? As a developer, is it useful for me? Yes or no?
Yeah. If you're scrolling through things and you're like, what is this? It's probably not useful.
Yeah. And also, if you log things that look like square bracket object, you are either you need it and therefore you need to fix the line, or you never needed it in the first place.
Yeah.
Yeah. I was thinking that the log level it actually really hit the sweet spot. You have the good advice on the blog. One scenario that I remember was that we shipped it to production, and I went through. I have 2 test suites for like just as I ship things, just to make sure things work, like smoke tests kind of thing. One is the automated one. It's written in our TypeScript client, which is open source. I just run it. If it works, fantastic. Just yes, no. The other is that sometimes you can also copy paste the REST APIs. I played with that. I wanted to try something. We also shipped cookies. I wanted to try cookies. When I did REST, nothing worked. So first I blamed cookies. We decided the cookies are not to blame. I reproduced it without cookies. But it sometimes worked, sometimes didn't. Sometimes they logged in, sometimes they didn't. Sometimes they managed to create an email, sometimes they didn't. It drove me insane. Luckily, the logs could see exactly who am I acting. So it was very clear that the ones are not logging in at all. Like, even if I think I'm logged in, something is wrong with the tokens that I'm passing. It does not know who I am. Incredibly clear. And then it was easy to find out that I misspelled bearer in the headers that says bearer token. And I spent 3 hours because I cannot spell bearer.
Oh no. Yeah, I haven't had. That's good. I haven't had one of those misspelling bugs catch me for a few hours in a while. It used to be a common problem in college. I would spend a full day debugging like a low-level systems assignment and would catch a spelling error. Oh my god. Yeah, those are rough. But logging definitely. If I had logging back then, maybe I would have got to sleep more.
What do you mean? When I was in college, logging was the only way of debugging. You print F until something.
Well, some nice logging. If I actually did it, if I followed my own, my future self advice.
We're almost at time. We need to invite you back to talk about our observability. Like this is a good point of discussion in its own right, because we do have a very nice framework for how to get the information we need. So almost at time. Any last bit of advice for developer building their first SaaS and going the multi-tenant route?
Yeah, it's a bit of higher level advice, but the thing I found really useful for myself, I've gotten a lot better at doing this, and I notice other people doing this all the time, is they build software in the way that they think software should ideally be built instead of doing it in realistic constraints. So for example, with row-level security, you can say you don't need something like row-level security if you just test every access pattern all the time. You have 12,000 integration tests. Why do you need something like this if you just test everything all the time? And surprisingly, a lot of people think this way. And I think optimizing for rare, hopefully, but inevitable human error is something that you should be doing. So this, I think, goes with like the chaos monkey stuff from Netflix and the idea that distributed systems always fail, and you design for failure. You don't design for just flawless systems. This is a good practice when developing things like this. So it's that's something that I think in the long run saves you a lot of time and just allows you to be a lot more confident when you're developing things. Generally, when you're more confident, you can just move faster.
And like just cognitive faults in humans. The fact that we I think there's a book, Predictably Irrational. I have not read it, so I cannot recommend.
Right.
But
I do recommend it.
You do recommend it. Okay.
It's nice.
So the idea that human cognition fails in predictable ways, and you can take it into account when you're designing systems for well-known, well-proven cognitive failures in human beings. Like this wetware is also, maybe it's been debugged over a million years of evolution, but it's definitely not bug-free.
No, definitely not.
So we also have a book recommendation now. You said it's Predictably Irrational, right?
Yeah, by January. It's a good. It's more like a pop sci read. I can't recommend it if you're super serious about the subject, but it's entertaining.
I'll add it here as a good read. Cool. We're at time. Thank you so much for joining us this morning, Miki. It's been an amazing conversation.
Yeah, I had a lot of fun. Thank you for allowing me to be on my first podcast.